On a cool morning in late February in the year 1943, the desert of central Tunisia still carried the scars of recent battle. Burned scrub marked the lines of artillery fire, and twisted metal lay half buried in sand where tanks had been stopped in place. For the soldiers of the 1st Armored Division of the United States, this landscape had already become familiar, yet it still felt hostile and uncertain. In those months, one image overshadowed the rest. It was the dark, boxy silhouette of the German medium tank known as the Panzer IV. Allied training films had used its shape again and again as a warning. In lecture tents and briefing huts, instructors had repeated the same message. German armor was said to be thicker, better sloped, and more cleverly engineered than anything that American or British factories were sending across the ocean. For many crews, these warnings had been reinforced by stories from the earlier desert fighting. British units had already faced panzer formations in Libya and Egypt. Reports that spread through Allied ranks stressed how often British tanks had been knocked out, and how hard it seemed to be to destroy German machines in return. Even when the details were incomplete, the tone was consistent. The Panzer IV was presented as a symbol of German technical superiority, and the lesson sunk in. Lieutenant James Bates had absorbed that lesson long before he ever saw a German tank with his own eyes. As an officer in the 1st Armored Division, he had trained on the American medium tank later known to the world simply as the Sherman. In exercises he had learned where to position his vehicle, how to angle armor, and how to work with infantry and artillery. Yet in the background there was always that image from the training films. A dark German tank rolling forward through smoke while shells bounced harmlessly from its front. On the 23rd of February near the town of Sidi Bou Zid, the gap between those images and reality began to narrow. The fighting in that sector had been intense. German and Italian units had launched coordinated attacks that pushed American positions back and disrupted their lines. In the aftermath, patrols moved carefully through the area, searching for wounded, recovering equipment, and checking that seemingly silent vehicles were not still a threat. It was during one of these inspections that Bates saw the shape on the horizon. Against the pale sand, the tank stood out at once. Its turret was turned slightly to one side and its long gun pointed at nothing in particular. There was no smoke coming from it and no movement near it, which made it more unsettling rather than less. In training material, a Panzer was almost always shown in motion. Here it was simply still. As he drew closer with a small party of men, the details sharpened. The familiar side plates of the Panzer IV became visible, along with the distinct road wheels and the angular turret. There were no bodies nearby, no signs of a recent explosion. One track was damaged and partially thrown from its wheels, which explained why the vehicle had stopped. The hatches on top were open, dark rectangles cut into the lighter color of the armor. The crew had climbed out during the night and left the machine where it stood. For the first time, Bates was able to walk slowly around a German tank that was not firing at him. He could study the armor from a few paces away rather than through the haze of battle. The front plate showed marks where small arms fire and fragments had struck, but it was intact. The side plates carried longer scars where something heavier had grazed along the surface and then deflected away. To a man who had been told that this armor was nearly impenetrable, the sight was strange. The metal looked solid but not mystical. On the leading edge of the hull, where the front plate met the side, he could see the actual thickness of the steel. The desert light fell cleanly across that edge and made it possible to judge its size by eye. It did not look like the massive barrier he had imagined when hearing claims of 80 or even 100 millimeters of armor. It seemed closer to the thickness of his own medium tank, which he knew well from training and maintenance. That observation did not prove anything by itself, and Bates knew it. In the field, impressions could be misleading, and angles could play tricks on the eye. At the same time, a small tension began to form between what he was seeing and what he had been taught. The German tank in front of him was a real object with measurable dimensions. The German tank in his memory was a collection of stories and warnings. The two did not fully match. He noted the pattern of damage on the front. The tank had been stopped without a catastrophic explosion. The crew had clearly had enough time to leave it and withdraw under cover of darkness. That meant it had either been immobilized by damage that did not shatter the hull, or it had broken down mechanically under stress. In both cases, the picture was different from the invulnerable machine of the training films. It was powerful but not invincible. It could be forced to stop. Around that time, word was spreading among American units that specialized ordnance teams were moving through the theater. Their task was to examine captured enemy equipment in a systematic way and to record measurements with precision instruments. They brought new tools, including gauges that could measure armor thickness without cutting into the plate. These teams were gathering data for reports that would later guide both tactics and design. The disabled panzer near Sidi Bouzid quickly attracted their attention. It was relatively intact, accessible, and represented the most common German medium tank then in use against the Allies. For an ordnance officer like Captain Robert Clark, it was exactly the sort of find that could turn guesswork into solid numbers. Arrangements were made to secure the area around the tank and prepare it for careful study. As the day went on, the battlefield slowly emptied of frontline troops. Patrols returned to their units. New positions were dug, and commanders considered their next moves in the fast-changing campaign. The Panzer IV remained where it stood, its gun silent, its open hatches facing the sky. It was no longer a direct threat, but it had become something else, a physical question waiting for an answer. Soon, the ordnance team would arrive with their instruments and clip sensors to the steel. They would crawl over the hull, record readings, and compare every result with the assumptions that had shaped Allied thinking since the first months of the war. For Lieutenant James Bates, the memory of that morning would stay linked to a single feeling: the sense that the fear surrounding German armor had begun to crack, even before the numbers were written down. The full scale of that change, however, was still just ahead. When the ordnance team finally reached the disabled Panzer, the desert sun was already high enough to wash the metal in a flat white glare. The tank no longer looked dramatic. It simply sat there as a piece of machinery, dusty and silent, its once sharp paint dulled by sand and heat. Yet for Captain Robert Clark, an ordnance officer sent forward from the rear, it was the most important object in sight. Clark had come with a small group of specialists and a set of new instruments packed carefully in wooden cases. Among them were ultrasonic gauges, devices that could send pulses through steel and read the time those pulses took to return. From that timing, the machines could calculate thickness with more certainty than any guess made by eye. These tools were not flashy and they did not look like weapons, but in a war built on numbers and logistics they were powerful in their own way. Before they approached the tank, Clark reviewed what Allied intelligence believed about it. Reports compiled from early battles claimed that the frontal armor of this model reached values close to 80 millimeters or even more. Those figures had been repeated often enough to feel solid. Training material, lecture notes, and briefings had used them as a base for tactics. Crews had been told that their own medium tanks, with frontal plates a little over 50 millimeters thick, were outmatched and needed to rely on maneuver rather than protection. At the same time, there had always been gaps in the data. Many of the early reports came from hurried battlefield inspections or from partial wrecks that had been hit by heavy guns. It was hard to tell original thickness from torn edges and shattered plates. Some estimates simply tried to match the fear that frontline units described. If soldiers felt their shells were bouncing off, it was easy for analysts in the rear to imagine armor that was almost impossibly strong. Now, for once, Clark had something better. The Panzer IV near Sidi Bouzid was not a burnt-out shell or a pile of twisted parts. It was a mostly intact vehicle that had been stopped without its hull being destroyed. The tracks were damaged, there were scars on the armor, but the plates were still whole. That made it ideal for careful measurement. The ordnance team moved in close and began their routine. They checked the area for mines and booby traps, examined the inside for any remaining ammunition, and made sure the gun could not be operated. Once satisfied that the tank was safe to handle, they started their work on the armor. The gauges were unpacked, cables were run out, and small sensors were pressed against cleaned patches of steel. On each major surface, the procedure was the same. A thin layer of grease was spread to help the sensor make good contact. The gauge emitted a brief pulse, then listened for its echo. On the dial, a needle or a digital reading showed the result in millimeters. Every measurement was written down by hand in a notebook, along with location and angle. There was nothing dramatic about it. The only sounds were the quiet clicks of instruments, the scratch of pencils, and the occasional gust of desert wind. At first, the numbers did not seem remarkable. On the side plates, the readings clustered around values that matched what Clark already expected for a German medium tank. They were thick enough to stop many types of fire at longer ranges, but nothing like the titanic armor of the heavy tanks that designers on all sides were already imagining for the future. It was when they began to work on the frontal plate that the tension slowly rose. This was the area that mattered most to crews in combat. It was the surface that advanced toward the enemy, the face that caught incoming rounds as tanks tried to bring their guns to bear. If the stories of nearly unbeatable armor were true, the truth would be hiding here. The sensors were placed, the pulses were sent, and the first reading appeared. It did not show 80 millimeters. It did not even show 70. The number hovered closer to 50. Clark checked the contacts, repeated the test, and watched the same figure appear again. He did not jump to conclusions. Instruments could fail. Surfaces might be irregular. They shifted the sensor slightly, tried another spot on the same plate, and then another, working methodically across the front. The readings changed only within small margins. In every case, they pointed to a frontal armor thickness around 50 millimeters. That was almost exactly the figure that Clark knew belonged to the frontal armor of the American medium tank, the Sherman. The team expanded their testing to other parts of the hull to look for any hidden regions of extraordinary thickness. They checked the gun mantlet around the base of the main cannon, measured the lower glacis, and even tested where additional plates might have been welded. In each place, the results stayed within a familiar range. They found no mysterious wall of steel that could justify the inflated values that had circulated through Allied channels. On a rough sketch of the tank in his notebook, Clark began to write in the confirmed figures. As the drawing filled with numbers, the shape of a more accurate picture emerged. The Panzer IV did not appear as a monster built from armor far beyond Allied standards. It looked instead like a solid, well-designed medium tank whose protection lined up closely with what American factories were producing at the same time. The implications were wide, but Clark still treated his work as unfinished. One tank, even carefully measured, was only a sample. Intelligence officers wanted to be sure they were not dealing with a special variant or an older model. To address this, he added detailed notes about the gun, the turret, the side skirts, and the fittings, all of which matched what was known of the current frontline version in service with German units in North Africa. Photographs would later support his observations and allow experts in the rear to confirm that this was not an exception but a standard enemy vehicle. Elsewhere in the theater, British examination teams were conducting their own studies on captured German tanks. They too were moving beyond guesswork, slowly building a set of numbers based on direct measurement rather than rumor. Unknown to each other at that moment, the American and British efforts were converging on the same conclusion. The armor of the German medium tank was not significantly thicker than that of the Allied medium tanks facing it. Back near Sidi Bouzid, the ordnance team continued its slow, patient work until the light began to fade. As they packed their instruments and secured their notes, the Panzer IV remained in place, now covered in chalk marks and grease stains from the testing. On its surface, no change was visible to the casual observer. To Clark, however, the tank had already transformed. It was no longer a symbol of overwhelming superiority. It had become evidence that a long-standing belief within Allied ranks might be wrong. Those notebooks, filled with careful digits and neat sketches, were destined for headquarters and analysis rooms far from the front. From there, they would climb through layers of staff, crossing desks and filing cabinets, until they reached the officers responsible for shaping doctrine and equipment policy. Before that happened, though, they would need to be checked, compared, and weighed against other sources. For the men at the front, nothing changed overnight. They still drove their Shermans into positions, still watched the horizon for dust clouds that might signal German armor on the move. Yet without knowing it, a slow shift had already begun. The numbers gathered beside that one disabled tank would soon start to push against the fear that training and rumor had built. The real scale of that shift would only become clear once the intelligence world had finished with Clark's report and sent its conclusions back down the chain. That process was only just beginning. Far from the dust and heat of Sidi Bou Zid, war looked different. In rear headquarters, the desert entered only through maps and photographs pinned to walls. Lines of colored pencil traced advances and retreats across Tunisia, while small flags marked units that most staff officers would never see in person. In these rooms, the war was measured in reports rather than explosions, and the fate of entire campaigns could shift on a few pages of careful writing. The notebooks that Captain Robert Clark carried out of the desert made their way into this world step by step. First, they were bundled with other technical documents and loaded onto a truck. Then they were passed from one office to another, accompanied by brief cover notes that did little to hint at their importance. By the time they reached the analysts responsible for enemy equipment, the pages were just one packet in a growing stack of data from North Africa. When Clark sat down to turn his field notes into a formal report, he followed the expected pattern. He began with a clear description of the captured vehicle. He noted its model, its gun type, its general configuration, and the condition in which it had been found. He attached sketches of the hull and turret, marked with the precise locations where his team had taken their measurements. Then he wrote in the numbers themselves. Across the frontal plate of the Panzer IV, he recorded thickness values concentrated around 50 millimeters. On the sides and rear, he logged slightly lower figures, consistent with medium tank design focused on protection from the front. Nowhere on the hull did he find armor that matched the inflated estimates that had been circulating in training material. He stated this plainly, and then took the next logical step. He compared those values directly with the known figures for the American medium tank, the Sherman. The Sherman's frontal armor, a 51mm plate set at a significant slope, had long been understood by designers to offer better effective resistance than a flat plate of the same thickness. Armored warfare specialists knew the physics. A sloped surface forced incoming rounds to travel through more metal and increased the chance that a shot would deflect instead of biting straight in. On paper, a sloped 50mm plate could match or exceed the performance of a much thicker flat plate. Clark laid this out in calm technical language. The German medium tank and the American medium tank, he explained, had broadly comparable levels of armor protection. In some cases, especially at typical combat angles, the Sherman's sloped frontal plate offered equal or better effective resistance than the Panzer's flatter nose. He did not claim that one machine was categorically superior in every way. Instead, he carefully dismantled the idea that German armor was in a different league altogether. The report moved upward through the intelligence system in the usual way. Clerks filed copies, section heads initialed margins, and technical specialists added comments. Some readers accepted the numbers on sight. Others paused, checking them against earlier documents that spoke confidently of German armor in the range of 80 to 100 millimeters. The contrast was sharp. For a moment, paper clashed with paper. To resolve the conflict, analysts reached out to their British counterparts who had been studying captured tanks since the earlier desert battles against the Afrika Korps. From workshops and proving grounds in Egypt and the Middle East, replies arrived with their own data tables and photographs. Independent British measurements of Panzer IV hulls showed the same story. Frontal plates around 50 millimeters. Side armor noticeably thinner. No hidden slabs of extraordinary steel. The convergence was hard to ignore. Two allied nations, using their own teams and instruments at different times and places, had arrived at the same essential conclusion. The German medium tank was not wrapped in the near-mythical armor that earlier estimates had described. Its protection sat squarely within the range expected for a vehicle of its class. For the officers responsible for intelligence summaries, this forced a reassessment. They began to look back at the sources that had created the earlier myth. Much of it, they now saw, came from the opening years of the war, when German forces had swept through Poland, France, and the Low Countries with shocking speed. Newsreels had shown images of German tanks rolling past wrecked enemy vehicles, and those images had traveled around the world. In many cases, the causes of the wrecks were complex, involving tactics, air support, and poor coordination, but audiences tended to connect them directly to supposed German technical superiority. Later, in the desert fighting between German and British forces, incomplete reports had reinforced that impression. When British crews felt that their own shells struggled to stop advancing panzers, the easiest explanation was that the enemy armor must be drastically thicker. Few had the chance, in the middle of that hard campaign, to measure surviving German vehicles with scientific tools. Fear and respect filled the gap where data was missing. Instructors who later trained American crews had relied on those early conclusions. They had repeated the idea that German tanks enjoyed a clear advantage in protection and had encouraged tactics built around avoiding direct hits rather than trading blows. The intention, to keep crews cautious and alive, was understandable. Yet over time, the tone of those lessons had hardened into a fixed belief that the enemy's armor was something close to untouchable. Clark's report and the matching British data sets did not only offer new numbers. They offered a way to reframe that entire story. If German medium tanks and Allied medium tanks carried comparable armor, then the outcome of many earlier battles had to be reconsidered in a different light. Success or failure at the front had depended less on metal thickness and more on training, coordination, use of terrain, and the presence of air and artillery support. The implications slowly filtered into official documents. Intelligence summaries began to include corrected armor values for German vehicles. New editions of recognition manuals, the booklets that tank crews used to identify enemy types at a glance, began to adjust their tables. In draft form, revised training notes suggested that Allied crews should no longer assume that their own armor was inferior in every exchange. Instead, they were encouraged to think in terms of matchups between broadly equal machines where positioning and first sighting mattered enormously. Out in the field, however, little of this had yet reached the men who needed it most. In Tunisia and beyond, Sherman crews still tended to imagine that every panzer they saw could absorb more punishment than they could. They angled their tanks cautiously, stayed hull down whenever possible, and often hesitated to expose themselves even when a bold move might have given them an advantage. The weight of an old idea does not lift quickly, even when new figures are already sitting on desks in the rear. For the moment, the story of the captured panzer near Sidi Bou Zid remained bound up in folder covers and filing cabinets. Its armor had been measured, its numbers written, and its significance recognized by a small circle of specialists. The next step would be harder. Those findings would have to travel all the way back to the desert and into the minds of the crews who still watched the horizon with a mix of caution and dread. The gap between what was true on paper and what was believed in the turret was still wide open, waiting to be closed. The first signs of change did not arrive in the form of a dramatic announcement. They came in small details that most soldiers might have missed at a glance. A new intelligence summary pinned to a notice board. A revised recognition manual tucked into a dispatch. A few extra pages in a training booklet that had once seemed fixed in place. Somewhere in those pages sat the work of Captain Robert Clark and the British teams who had measured German armor with care instead of fear. For the armored units of the United States, the shift became more noticeable as the war moved on from North Africa to new stages. After the fighting in Tunisia wound down, many Sherman crews found themselves rotating through training areas rather than going straight into another major campaign. In those camps, far from immediate danger, there was time for lectures, demonstrations, and long sessions around sand tables that tried to turn raw information into practical lessons. In one such camp, a group of tank crews sat through what looked at first like another standard briefing on enemy armor. The familiar outlines appeared on the board at the front of the room. The heavy nose of the Panzer IV. The rounded turret of older German models. The blockier shapes of self-propelled guns. The men had seen these drawings many times before. They had been told where to aim, how to recognize different versions, and how to avoid common mistakes. What changed now lay in the numbers written beside those shapes. Where early diagrams had suggested thick walls of steel across the front of the Panzer IV, the new material showed something different. The frontal armor was listed close to 50 millimeters. The instructor pointed out that this matched the thickness of the Sherman's own front plate, and then underlined a detail that had rarely been stressed with such confidence before. The American plate was sloped, which gave it a higher effective value in many real engagements. Some men in the room reacted inwardly with a kind of quiet suspicion. For years they had been told the opposite, and in war a belief repeated often becomes hard to dislodge. They remembered older training films where shells seemed to bounce from German armor without effect. They remembered stories from veterans of early desert fighting who had described the Panzer as something close to indestructible from head-on. Now, on a calm afternoon far from the front, they were being asked to accept that the enemy medium tank was not so different from their own. The briefing did not rely on enthusiasm or slogans. It leaned on data. The instructor explained that the new figures came from careful measurement of captured vehicles, not from rumors or guesses. He described how ordnance teams had used gauges to read thickness directly from intact plates. He showed photographs of German tanks lying silent in the desert, their armor intact but their tracks broken or their internal systems damaged. The message was simple. These machines could be stopped, and their protection was not beyond Allied standards. Alongside armor values, the updated material also talked more openly about gun performance. Charts now made clear that the long German 75mm gun mounted on later Panzer IVs could punch through armor at ranges where the standard American 75 sometimes struggled. The German gun could manage around 90mm of penetration at 500 yards under test conditions, while the American piece hovered closer to 60. This meant that, in a straight trade of shots, the German crew often had a better chance of scoring a decisive hit first if both sides exposed themselves equally. Instead of letting that fact crush morale, instructors tied it directly to tactics. If armor was roughly equal, but the enemy gun was stronger, then the answer lay in how and where the Sherman was used. Emphasis grew on flanking maneuvers, on using terrain to mask movement, and on coordinating with artillery and aircraft to disrupt German formations before they could bring their main guns fully to bear. The new narrative did not say that Allied tanks were superior in every way. It said something subtly different. They were good enough, and their crews could win by thinking clearly rather than by hiding in fear. For many tankers, the psychological shift did not happen at once. Some remembered how they had felt the first time they saw a Panzer through dust and smoke. The image of that dark shape on the horizon carried weight. It had been tied to warnings, stories of defeat, and the natural fear of facing an enemy who seemed to have every advantage. Now they were being told that this same shape represented a machine much closer to their own in protection. The mind needed time to reconcile those two pictures. Yet as weeks went by, the idea began to settle. Practice exercises reinforced it. Crews ran drills where they drove Shermans against mock German positions on training grounds, applying the new guidance on angling armor and choosing positions. They learned to trust that, if they kept their fronts sloped toward the enemy and avoided careless exposure of their thinner side plates, their tanks could survive hits that might once have been assumed fatal. In after-action discussions from smaller skirmishes and patrols, stories started to surface that matched the new intelligence. In some fights, Shermans had taken hits on their frontal armor and remained in action long enough to return fire and withdraw. In others, Panzer IVs had been knocked out by well-placed shots from American guns at moderate ranges. Each such example, when shared across units, chipped away at the idea that German armor was on a different level altogether. Inside headquarters, analysts tracked combat statistics with the same care that ordnance officers had used on steel plates. They tallied tank losses and kills by type, by front, and by time period. Early figures from encounters with German armor had often shown rough parity or even unfavorable exchanges, with American units losing more tanks in a given clash than they destroyed. As experience grew, and as corrected intelligence and better tactics took root, those ratios began to shift. Internal studies later pointed to improvements, with some formations reporting kill-to-loss ratios that moved from slightly negative toward slight but significant advantages by the middle of 1944. On paper, those numbers looked dry. In the field, they translated into a growing sense that Sherman crews could meet Panzer IVs as equals rather than as underdogs. The new view of German armor did not erase the danger. A wrong move could still end a crew's war in a single flash of heat and metal. But it replaced a heavy, vague fear with something more specific. Instead of thinking the enemy tank was wrapped in unbeatable steel, crews could think in terms of gun ranges, armor angles, and fields of fire. As preparations for larger operations gathered pace, especially in the build-up to landings in Western Europe, This more balanced understanding of the Panzer IV found its way into planning documents and training plans. The German medium tank was still respected as a capable opponent, but it was no longer cast as a legend. It was treated as one piece in a wider German arsenal that also contained something new and more worrying. Reports from the Eastern Front and later from Italy spoke of heavier tanks with thicker armor and more powerful guns, machines with names that would soon become famous on every front. Those heavier vehicles, the Panther and the Tiger, represented a different level of challenge altogether. Their appearance did not erase the progress made in understanding the Panzer IV, but it did shift attention. For Sherman crews who had just begun to accept that German medium armor was not superior, there was a new question forming in the background of their thoughts, silent but growing. If medium tanks were now a fair fight, what would it mean to face these heavier German designs whose armor figures really did sit far above their own? By the time the fighting moved on from North Africa to the rugged hills of the Italian peninsula, the corrected view of German armor had begun to filter through the Allied armies in uneven waves. It traveled in briefings, in new manuals, and in the quiet comments of officers who had read the latest intelligence summaries. For many tank crews, it arrived late and in fragments, colliding with memories that were hard to set aside. Some of the men who had faced German armor in the earlier battles reacted with a feeling that was not simple relief. They remembered sitting in dusty tents, watching training films that seemed to prove German tanks could shrug off hit after hit. They remembered instructors repeating that the enemy's armor was far thicker and stronger than anything welded onto their own machines. Now they discovered that, at least for the Panzer IV, much of that fear had been built on wrong numbers. The first reaction for some was anger, quiet but sharp. They thought of friends lost in battles where every German tank on the horizon had seemed like a giant. They wondered what choices they might have made if they had known that their Shermans carried armor roughly equal to their opponents, and that careful use of that armor might have given them more options. In conversations held out of earshot of senior officers, words like overstatement and scaremongering floated around small campfires. At the same time, another feeling grew alongside the anger. It was a kind of spreading relief that many found hard to admit out loud. The idea that German tanks were wrapped in an almost magical layer of protection had weighed heavily on their minds. To learn that the Panzer IV's frontal armor was closer to 50 millimeters, not the 80 or 100 whispered in training, lifted some of that weight. The enemy's machine was still dangerous, still armed with a strong gun, but it no longer belonged to a different world. The Italian campaign offered fresh ground on which these new ideas could either prove themselves or fail. The landscape, with its steep ridges, narrow valleys, and stone-built villages, did not resemble the open spaces of North African deserts. Tanks fought there too, but often at shorter ranges and under the constant threat of well-sighted anti-tank guns hidden among buildings or behind stone walls. In this environment, armor values and gun performance still mattered, yet so did every detail of positioning and cooperation. Sherman crews moving through the Liri Valley or along the approaches to Cassino now did so with a more balanced picture of their German opposite numbers. When reports mentioned Panzer IVs holding a ridge or covering a road, the men no longer imagined impenetrable beasts waiting in perfect safety. They pictured vehicles whose armor could be defeated if they were caught in a crossfire, hit from the flank, or struck at closer range. They knew that their own frontal plates, when kept sloped and partly hidden behind cover, could stand up to more punishment than earlier fear had allowed them to believe. Battle reports from Italy began to reflect this change in tone. There were still engagements where Shermans were knocked out in worrying numbers, especially when they were sent forward without adequate infantry or artillery support. German guns, whether mounted on tanks or on towed anti-tank carriages, remained capable of destroying Allied vehicles with brutal efficiency when given clear shots. But there were also more accounts of Sherman units pressing attacks, holding ground under fire, and surviving exchanges that might once have prompted immediate withdrawal. In some actions, American tanks took several hits on their frontal armor and remained in the fight, their crews shaken but alive. In others, they succeeded in disabling Panzer IVs by hitting weaker side plates or by firing when German crews were forced to expose themselves while changing position. Every such episode, written up in after-action notes and passed along informally by word of mouth, added a small piece to a growing puzzle. The picture that emerged showed two families of medium tanks, different in design and armament but much closer in overall resilience than earlier stories had claimed. In briefing tents, instructors began to frame the comparison more clearly. They stated that the Panzer IV still enjoyed an advantage in firepower when equipped with its long-barrel 75mm gun. At common battle ranges, that weapon could pierce armor more reliably than the short-barrel 75 on many Shermans. This truth was not softened. Crews were reminded that showing their tanks broadside to such guns was close to suicide. The lesson, however, now came paired with another. Their own armor, especially from the front and at a good angle, was not the weak shell that fear had painted. Because of this, exercises placed greater emphasis on deliberate movement and mutual support. On Italian training grounds set back from the front, Sherman crews practiced advancing by bounds, one element covering while another moved. They rehearsed using the terrain in front of them, choosing hull-down positions where only the strongest parts of their own armor were exposed. They were taught to trust that, if they followed these principles, they could stand up to German fire long enough to deliver their own shots. Psychologically, this was a shift from viewing battle as an attempt to avoid being seen at all, toward viewing it as a contest between roughly equal machines where the first accurate hit and the best use of ground made the difference. In quiet moments, some veterans found themselves rethinking episodes from earlier fights in North Africa. They replayed maneuvers in their minds and wondered how they might have acted had they not believed that every frontal confrontation with a Panzer IV was a hopeless gamble. The past could not be changed, but those reflections shaped decisions in the battles still to come. Commanders at higher levels watched the results with interest. They noticed that units which fully absorbed the new view of German armor tended to show more initiative in battle. These formations were more willing to seize opportunities when German tanks overextended or exposed their flanks. They were also quicker to coordinate with artillery and air support, knowing that every suppressed or disrupted panzer unit represented a chance for their own medium tanks to close the distance and bring their guns to bear. Meanwhile, in factories and design offices far from the front, another response was taking shape. Engineers and planners studying the same intelligence reports concluded that, if armor parity had been largely achieved in the medium tank class, the next logical step was to address the imbalance in gun power. Work accelerated on fitting Shermans with a higher velocity 76mm weapon that could challenge the Panzer IV more effectively at typical combat ranges. These developments were still in transition as the Italian campaign ground onward. Not every unit received the newer gun at once, and some crews would go through their entire service with the original short-barrel 75. Even so, the direction was clear. The Allied response to earlier fear of German armor was no longer to imagine impossible thicknesses of steel on their own tanks, but to understand the real balance of protection and firepower and to adjust accordingly. In the minds of many Sherman crews, one fear faded only to be replaced by another, more focused one. The Panzer IV no longer seemed like an untouchable monster. It was recognized as a tough but mortal opponent. Yet reports from other fronts, especially from the long struggle on the Eastern Front, spoke of German tanks that did in fact carry armor figures far beyond those of the standard Allied medium vehicles. Names like Panther and Tiger began to appear more often in written briefings and casual conversation. These machines, if the reports were accurate, might restore in reality the same sense of imbalance that had once surrounded the Panzer IV in rumor. As preparations for a major landing in Western Europe moved forward, those names cast a long, thin shadow over the planning rooms and training fields alike. The myth of the German medium tank had been measured and found wanting, but at the same time, a new and more serious challenge was taking shape on the horizon. In design offices and planning rooms far from the front, the corrected numbers on German armor landed with a different weight than they did in field camps. For engineers, draftsmen, and ordnance officers, the news that the Panzer IV's protection was roughly on par with the Sherman's armor did not feel like a surprise or a betrayal. It felt like a problem that had finally been defined clearly enough to solve. For years, the United States had treated the Sherman as a workhorse medium tank, designed above all for reliability and mass production. Its armor scheme, with a sloped 51mm front plate, reflected a compromise between protection, weight, and mechanical stress. The tank had been built to cross oceans and then roll for long distances without constant breakdowns. That aim had been largely achieved. The new intelligence on German armor levels suggested that this basic balance had not been far off. The Sherman could meet the Panzer IV on roughly equal terms in terms of staying power. The real imbalance lay in firepower. Reports from Tunisia and then from Italy, combined with test range data, made the point plain. The long-barrel German 75mm gun mounted on later Panzer IVs, and on various German assault guns, could penetrate armor that the standard American 75mm struggled against at similar ranges. At 500 yards, under controlled conditions, German test figures around 90mm of penetration were not unusual. American figures for the Sherman's guns sat much lower, close to 60, depending on ammunition and target. For tank crews, this difference had meant that a Panzer IV which saw a Sherman first could often destroy it with a frontal hit, while the Sherman sometimes needed a shorter range or a better angle to punch back with the same effect. For designers, it meant that any attempt to level the field could not rely on armor alone. Simply adding more steel to the Sherman's nose would have pushed its weight up, strained its engine and transmission, and caused all sorts of new logistical problems. The more efficient route was to raise the Sherman's offensive power, so that it could threaten enemy tanks at the same ranges where it was already under threat. Within ordnance circles, discussions about a higher velocity gun for the Sherman had already been underway. Various designs had been tested on paper and on proving grounds, but the new intelligence gave those projects sharper urgency. If the armor race in the medium tank category was essentially even for the moment, then the natural next step was a gun that could match or exceed the performance of the Panzer IV's weapon without turning the Sherman into a completely different machine. The result of this push was the 76mm gun that would eventually arm a significant number of Shermans. Compared to the original 75, the new weapon fired lighter, faster-moving projectiles. In tests, it showed a much improved ability to penetrate armor at medium to long ranges. Its longer barrel and higher muzzle velocity promised that, if crews could place their shots well, they would no longer enter an engagement with German medium tanks at a built-in disadvantage. The path from drawing board to battlefield was not simple. The 76mm gun required adjustments to the Sherman's turret to handle its recoil and balance. Production lines had to be modified, training manuals updated, and ammunition supply chains expanded to include new types of shells. At the same time, not every commander was immediately convinced that the trade-offs were worthwhile. The original 75 had been valued for its versatile high-explosive shell, which infantry units liked for its ability to knock out field positions and light fortifications. A gun optimized more heavily for armor penetration risked losing some of that flexibility. Even so, as reports of combat with German armor accumulated and as the fear around Panzer IV armor gave way to a more sober understanding of German gun strength, support for the 76mm Sherman grew. Test demonstrations showed that, against Panzer IV front plates at realistic angles and ranges, the new gun had a much better chance of achieving full penetration. In comparison charts pinned to office walls, the Sherman equipped with the 76 began to look less like a purely defensive vehicle and more like an active tank fighter in its own right. Across the Atlantic, British planners were following a parallel track with their own solution. They had developed the powerful 17-pounder anti-tank gun, a weapon with impressive armor-piercing performance. Rather than designing a new tank from the ground up, some British teams set about fitting this gun into the Sherman's turret. The resulting variant would become known informally as the Firefly. It represented a different answer to the same problem that Clark's report had helped clarify. If German armor was not vastly superior but German guns were dangerous, then the Allied response had to focus on putting stronger guns into the field without waiting for entirely new tank designs. These decisions were driven as much by time pressure as by engineering logic. The war was moving quickly. Plans for a cross-channel invasion, which would eventually become the Normandy landings, were gathering detail. Every year spent designing and testing a completely new Allied tank would be a year in which German industry continued to field improved versions of existing models. Medium tanks like the Panzer IV were receiving refinements, including additional armor plates and better optics. Newer designs such as the Panther were already appearing in larger numbers on the Eastern Front and in smaller numbers in the West and in Italy. In this context, enhancing the Sherman rather than replacing it outright made sense. The tank's mechanical reliability and ease of production were assets that commanders were reluctant to sacrifice. Its armor, once thought weak in comparison to German standards, now appeared adequate when used correctly. To make the most of that adequacy, a gun upgrade offered a practical path forward. While engineers and ordnance officials worked through these technical issues, doctrine writers continued to adjust the way Shermans were meant to fight. Training literature now treated engagements with Panzer IVs as contests that could be shaped by careful planning rather than as desperate attempts to avoid a superior machine. Manuals stressed that, in battles between two broadly similar medium tanks, the side that spotted first, fired accurately, and coordinated support assets would usually prevail. As more 76mm Shermans rolled off production lines, this doctrine found a clearer physical focus. Crews and units scheduled for future operations were told that their tanks would soon carry a gun capable of meeting the Panzer IV on better terms. They practiced identifying weak points on enemy armor, drilled on range estimation, and learned to conserve ammunition for moments when a hit could make the most difference. The sense of being outgunned began slowly to fade, at least in relation to German medium tanks. Of course, other concerns crept in to replace it. Reports about Panther and Tiger tanks continued to circulate, carrying descriptions of armor thicknesses that truly did exceed what even a 76mm gun could handle comfortably from the front at longer ranges. Yet the existence of a more capable Sherman gun meant that Allied crews could at least imagine strategies for dealing with those heavier vehicles, such as flanking attacks and coordinated efforts with artillery and air power. In quiet corners of ordnance offices, some officers reflected on how different this path had been from the one suggested by the early myths about German armor. If those myths had never been challenged by field measurements and careful reports, it was possible that Allied planners would have chased thicker armor on their own tanks at the expense of reliability and numbers. Instead, the recognition that the Panzer IV's protection was not uniquely formidable allowed them to focus on a more balanced improvement, raising firepower while keeping existing strengths. The first Shermans fitted with the 76mm gun began to reach units in time for the later stages of the Italian campaign and the build-up to Normandy. Their arrival did not transform the war overnight. Many formations would still go into major battles with a mix of older and newer gun types. Nevertheless, their presence marked a turning point. The process that had begun with a single disabled German tank near Sidi Bouzid, and with an ordnance team pressing gauges against its armor, had now reshaped not just beliefs but steel and machinery. As transports and landing ships assembled in British ports, preparing to carry Allied armies back onto the soil of Western Europe, rows of Shermans waited on docks and in storage yards. Some carried the familiar short-barrel 75. Others, newer and slightly different in outline, bore the longer barrel and distinct profile of the 76. The men who would soon crew them had absorbed revised intelligence on German armor and had trained under doctrines built on that intelligence. They still feared what waited behind the hedgerows and fortified lines of France, and with reason. The German army there would include both Panzer IVs and the newer heavy tanks that had begun to haunt Allied planning. But unlike the early days of the war, when shadowy myths surrounded every German armored silhouette, the crews now carried something else with them. They had data, experience, and machines designed in direct response to measured reality rather than to rumor. The next test of that reality would come soon, on the fields and in the villages of Normandy, where the evolving balance between Sherman and Panzer would be decided under the harshest possible conditions.